So for this lesson, just continuing the ideas from before, which is understanding what rational exponents represent and how they connect to radicals of different types, and how any radical can be expressed as a rational exponent and vice versa. So just continue with that. So for these first two, I want to evaluate them. So remember that means I want to calculate an overall value for an answer without using a calculator, as it says. So if I look here, keep in mind if the first thing I do is square 5 and get 25, well, the cube root of 25 isn't terribly helpful to me because 25 is not a perfect square. Sorry, it's not a perfect cube, it's a perfect square. So how can I evaluate this without starting off by trying to estimate the cube root of 25? Well, let's not write 5 as 20. Let's not write 5 squared as 25. Let's take this and write it as a power. And so I get 5 to the power of 2/3. And take this, and I get 5 to the power of 1/3. And so how is that helpful? Well, the good thing about this is once I write them as powers, or with exponents, then I can perhaps see if any exponent laws would be useful. And in this case, I'm multiplying two powers of the same base, so I can write this as a single power where I add my exponents. And suddenly, this comes together quite nicely, because 2/3 plus 1/3 is 1 whole. So this equals 5. 5 to the 1, or just, it's kind of silly to write 5 to the 1. Again, it's not wrong to write 5 to the 1, just kind of silly when I just write 5. There you go. This all equals 5 exactly. So similarly, if I look at this one here, more going on, but again, if we're going to try to evaluate this with a calculator, it should, we shouldn't have to estimate at some point. Again, I start with the square root of a number that in this case is not a perfect square. So whatever, 125 is a perfect cube. It's the same as 5 times 5 times 5, but it's not a perfect square. So let's just leave that alone. But I have a few options. One thing I can do is I have a power raised to another power. And anytime you have a power raised to another power, you can multiply those together. So I can write this as the square root of 125, all to the power of -4/6. That's it, -4/6. I might as well reduce to -2/3. All right, so it's already a lot simpler than we started with. Okay, what can I try next? Well, again, this square root I've been writing over and over again. I can write as a power of 1/2. So in fact, let me take this square root and rewrite it in this step here as a power of 1/2. So I'll write it like this. Oh, you know what? Maybe I'll do this in the next step. There we go. All right, and hopefully you can see my rationale behind doing that, because just because we can do something doesn't mean it's going to be helpful. So the reason I'm doing this is, again, I can use that same exponent law we started with. I have a power raised to another power, so I can multiply those two powers together. So I have 125 to the power of 1/2 times -2/3, which is -2/6, which again reduces to -1/3. And now I'm getting very, very close. A power of 1/3 is a cube root, and 125 is a perfect cube. So 125 to the power of 1/3 equals 5, because that's the same as a cube root of 125. However, I don't have a power of 1/3, I have a power of -1/3. So I got to be careful not to jump to a conclusion too quickly here, so close to the end. But let's ignore the 1/3 for a moment and just focus on the fact we have a negative power, and any negative power can be written as a positive power in the denominator in this case. So 125 to the -1/3 is equivalent to 1 divided by 125 to the positive 1/3. And now I can see how this finished this off, because 125 to the positive 1/3 is the same as the cube root of 125, which again, I've said from the start, is a rational number. The cube root of 125 is 5, and so this equals 1/5 in the end. And so, yeah, a lot of steps. Now keep in mind, I I pretty much showed you every single step I could. But yeah, a bunch of little steps. Notice I used the exponent laws a couple of times. I changed radicals to powers. I simplified these rational powers a few times. Lots of little things that connect back to many of our previous concepts. All right, so for both of these, though, definitely didn't need a calculator. All right, I only have one pair left, and this pair is to not evaluate but simplify these expressions. And as I ask, I want to write my answers with just exponents. Now, I don't want us to think that exponents are inherently considered simpler than radicals. Not at all. But any exponent can be written as a radical, and any radical can be written as an exponent. So just for the sake of keeping there from being too many possible answers, just stating I want the answers to be expressed with just exponents in the end. OK, let's focus on this one. So first thing I want to do is I want to write all these radicals with powers. So looking at this part, the cube root of the square root, so the cube root of 8 to the power of, helps so I can speak, the cube root of 8a to the power of 7, I can write as 8a to the power of 7, all to the power of 1/3. And while I'm at it, I'm finding the square root of all of that. So that means I can raise all of this to the power of 1/2. All right, so now let's look at these two powers right here. I have a power raised to another power, multiply them together. 1/3 times 1/2 is 1/6. So I have 8a to the power of 7, all to the power of 1/6. Now, let's be a little bit careful here. You could be tempted to say this, to just multiply these together and say this equals 8 times a to the 7/6, which is wrong. It's not terrible, but it is wrong. And that's because I'm ignoring that 8. And so keep in mind again, the 8 is not being raised to the power of 7, only the a is, which we can see from where the brackets are. So instead of doing that, I'm just going to raise everything here to the power of 1/6. Again, and a common mistake is just to ignore the coefficient for no logical reason. I mean, there's no reason I should ignore the 8 there. And so I can write this as 8 to the 1/6 times a to the 7/6. And now, if you compare this to what I started with, there is less going on. This is what I have here. Is simpler than what I started with, and everything's written with an exponent, but I'm not quite done yet. And all that's left is to think about this a to the power of 1/6. Now, I can simplify that a bit. I can't evaluate it nicely. The 6th root of 8 is not a pleasant number, but I can do something with this. And so I'm just going to take that and make a little note. And so if I take 8 to the 1/6, just notice that's the same as 8 to the 1/3, all to the power of 1/2. I'm kind of breaking up 1/6 into two separate powers. And again, maybe it's more obvious if you look this way. I have two powers raised to each other. You multiply them, 1/3 times 1/2 is 1/6. So I did that. But why did I do that? Because 8 to the 1/3 is the same as the cube root of 8, which is a very pleasant number. It's 2. And so this equals 2 to the 1/2. Which means 8 to the 1/6 is equivalent to 2 to the 1/2, the square root of 2, which is simpler. I mean, understanding the square root of 2, or 2 to the 1/2, is a simpler concept than understanding what 8 to the 1/6 is. The 6th root of 8 is, it's a bit more complex than the square root of 2. And so the last thing I want to do then is take this, my answer from before, and instead of saying 8 to the 1/6, write it as 2 to the 1/2 times a to the 7/6. And we're done. Again, a tough question, especially it's really easy to miss that this 8 to the 1/6 can be simplified a bit, even though we can't evaluate it down to a rational number. And that's probably what made it the most challenging. Last one. All right, so same idea. In the end, I want to write everything with just powers anyway, so why don't I just right away take this power, take this 4th root and write it as a power of 1/4. And then all of that is being raised to the 1/2. And again, one power raised to another, you multiply them together, and as we've seen many times over the last, actually many lessons, multiplying with fractions is quite pleasant. And so I have a cubed b to the power of 5, all to the power of 1/8. All right, so what can I do now? Well, not much more, but a bit more. I can raise all of these individual powers to an 8th, which means I can multiply 3 by an 8th and 5 by an 8th. So I get a to the 3/8 and b to the 5/8. And while my 8 looks a little messy there, let me clean it up a little bit. And now we're done. There's nothing more we can do. It's not like we can evaluate a or b. And again, compared to what we started with, that is simpler. Everything's been written as an exponent as requested. My fractions, my exponents, 3/8 and 5/8 are in lowest terms, so there's nothing more to do there. So we're done. We simplified it as much as we can. So keep in mind the point of these last few lessons is really just about gaining this proficiency with working with messier and messier roots and exponents. And realizing, while it's always more pleasant to think about a square root, there's nothing inherently more complex algebraically about dealing with a cube root or a fourth root or any root. And any root you deal with can be written as an exponent, and any exponent, rational exponent, can be written as a root. And that connection, that endless connection between these, is really the point behind all this. And the homework questions is a matter of practicing a greater and greater variety. And that's it.